Hello, students. This is for my class Monday, March 1st, and also Tuesday, March the 2nd. So our objective tonight is to determine the best method to use when factoring a polynomial. So just a quick review on the first one. If you have 4 terms, you can group them into 2 groups of 2. So now just looking at the first 2 terms, what do they both have in common? They both have a C, so we can factor out a C. So CQ divided by C is just Q, and then CU divided by C is just U. And then in our second set of terms, we see that they both have a positive Y. So if we pull out a Y, we would have Q plus U, and then notice that our parentheses match each other exactly. So one of our factors is Q plus U, and the other factor, we put these things together and we have C plus Y. And we could check our answer by foiling these 2 binomials, and we would get exactly what we had when we started. So we know they're equivalent. So just a quick review, that's how you factor when you have 4 terms, that's how you factor polynomials. All right, let's look at the next one. Now, we have been doing the AC method where you multiply A times C. Well, when the coefficient is 1, you can kind of skip that middle step. So for example, if we did 1 times 6, we decided that we needed 2 numbers that multiply to give us 6 and add to give us that middle term of -5. So we know that we'd have to have 6 and 1. And actually, they would both have to be a negative number. Nope, is that right? Nope, that's not going to work out. Oh, it's not 6 and 1, is it? It's going to be 3 and 2. So I was about to pick the wrong 2 numbers because I know I have to have 2 of the same sign to equal a positive 6. So -2 times -3 is positive 6, but then also -2 plus -3 equals -5. So remember how earlier we brought down the first term, we divided that second term into 2 numbers, which would be in this case -2x and then -3x, and bring down that fourth number. I meant the fourth number, which is a 6. And then we used grouping. Well, now because this coefficient is a 1, we're going to skip this section or this step, okay? So we're going to skip that step, and we're just going to go straight to factoring 2 numbers that multiply to give us positive 6 and add to give us -5. So we already wrote right here the answer, which is x minus 2 and then x minus 3. So we went straight from first step to the last step. We're cutting out that middle part when the coefficient of x squared is 1. So now if we FOIL this, we would get x squared minus 3x minus 2x, which is -5x. And then the last thing we would do is multiply -2 times -3 and get positive 6. So this is actually our final answer, and we did that in just 1 step. So let's try another one where we cut out that middle part of the AC method. So on this one, once again, our coefficient of x squared, or in other words, our A, is positive 1. So since it's positive 1 and 1 times -18 is -18, so in this situation, we need 2 numbers that multiply to give us -18 and add to give us -7. So to get the product of a negative number, we have to have a positive and a negative. So the factors of 18 are 1 and 18, 2 and 9. Can we do something with 2 and 9 to get -7? Yes, we can. So what if our 9 is negative? Isn't -9 plus +2 -7? It is. So we'll just go straight to the last step. We're going to find the square root of x squared, which is x and x. And then here are our two numbers we're looking for. So we're going to say -9 and +2. So now if we FOILed this, we would get x squared plus 2x minus 9x, which is -7x, and then -9 times +2 is -18. So this is our final answer. All right, now if you'll notice this one, this is a binomial, two terms, and do you notice that they're both perfect squares? 16 is perfect square and 9 is a perfect square. So when you have a binomial and they're both perfect squares and there's a negative sign between them or a minus sign, that is called a special product. And we're going to call it the difference of squares. Now, of course, difference in math means subtraction. So this only happens when that middle term or the sign that separates the two terms is a minus. So the way we're going to do this, go ahead and do your two sets of parentheses. We're going to find the square root of both of these terms. The square root of 16 is 4. So we're going to distribute the 4. The square root of 9x squared is 3x and 3x. Oh man, because don't you agree? 3x squared, previous, no, shoot. Oh, what did I do, you guys? Oh, kind of. All right, so don't you agree that 9x squared, the square root of 9x squared is 3x and 3x? Now, when there's a minus sign right there, that means that one of our parentheses get a plus and the other one gets a minus. And that's how you simplify the difference of squares. So now if we FOIL this to make sure, so first of all, this is our final answer, but now I want to check our final answer. So we're going to FOIL it. We're going to multiply the first two terms, which is 16. We're going to multiply our outside terms, which is 4 times -3 is -12x. Our two inside terms, which is +12x. And then our last two terms, 3x times -3x is -9x squared. Well, do you notice these two middle terms have opposite signs, so they cancel each other out? So we get what we started with. Okay, so this is our final answer. And how do we get this? We look at the two binomials. Well, that's redundant. We look at the binomial. If they're both perfect squares, and if there's a minus sign between them, this is how we factor it every single time. Okay, probably need to, we'll practice that again, okay? All right, so now, since we have a coefficient of 1 for letter A, we're going to go ahead and do two sets of parentheses. We're going to distribute y squared, which is y times y. Now we want two numbers that give us a product of -42, but a sum of +1. So think of the factors of 42. We have 1 and 42, 2 and 21, 7 and 6, right? Well, to get a negative product, one has to be positive and one has to be negative. To get a +1, that means the bigger number has to be positive. So 7 is going to say positive and 6 is going to be negative. So double check it. The 7 times -6 equal -42. Yep. Does 7 plus -6 equal -1? I'm sorry, +1? Yes. So we have a +7 and a -6. And guess what? That is our final answer. So we can do this with just one step. Okay, let's try this one right here. Since this is a 1, all we need is two numbers that multiply to give us 22 and add to give us 13. Well, if you think of the factors of 22, it's 1 and 22 and 2 and 11. Well, doesn't 2 times 11 equal 22 and 2 plus 11 equals 13, that means both terms are positive. So x plus 2 and x plus 11. And if we FOILed this, which is our final answer, we would get x squared plus 13x plus 22. All right, so those are just some reminders on how to factor. So let's see what else we have. All right, now this one, the first one on the left, looks really hard, doesn't it? But remember, when we have 4 terms, what we want to do is try to make those sets of parentheses match. Well, guess what? They already match. That means one of the factors is 2x plus 5. And then how do we always get the other factor? We put together what's outside the parentheses. So 7a to the third plus 6x. And guess what? We are finished. That's the final answer. Isn't that crazy? All right, now here we don't have a coefficient of 1. So we are going to do the AC method. We are going to multiply 5 times -6. We're going to multiply 5 times -6, which is -30. So since we're doing the AC method, we want 2 numbers that multiply to give me -30 and add to give me +7. Well, the factors of 30 are 1 and 30. I can't get 7 from those. 2 and 15. I can't get 7 from those. 3 and 10. Could I get a +7 from those? Well, if I had -3 times 10, I would get -30. And if I have -3 plus 10, I would get +7. So those are our 2 numbers, right? So since this is not a coefficient of 1, we're going to bring down our first number. We're going to bring down -3x. Now remember, we have to get 7x. So we have to add an x to these 2 numbers. Plus 10x. So -3x plus 10x is 7x. And then we bring down our last term. Now, since we have 4 terms, we're going to use our grouping method. Wait, hold on. Whoops, I didn't mean to do that. Sorry about that. All right, so now let's see what our common factors are. I'm sorry, guys. I'm trying to, I know you can't see the picture of me, but it's in my way, so I'm trying to move it. All right, so let's look at this first group. What do they have in common? Well, the only thing they have in common is an x. So I'm going to factor out an x. So I have 5x minus 3. And then what can I divide both of these terms by? A +2, right? So 10x divided by 2 is 5x. And -6 divided by 2 is -3. So here are 2 parentheses match. So one of my factors, let me get rid of some of this stuff. Get this stuff out of the way. All right, so what are my 2 factors? Well, the first one is what's in the parentheses, which is 5x minus 3. And the second set of parentheses is what's outside, which is x plus 2. And then I could double check my final answer by FOILing it, but I'm very confident that we got that one right. All right, once again, well, I was about to say this isn't a coefficient of 1, but then you have to pause and think, okay, can I factor something out of all 3 of these even numbers? Well, yes, since they're all even, I can factor out a 2. So 2x squared divided by 2 is x squared minus 8x plus 12. All right, so now this is a coefficient of 1. So all I do now, we're going to ignore this 2 for a minute. We're going to just ignore it. Now we're thinking of 2 numbers that multiply to give me 12 and add to give me -8. So we want 2 numbers that multiply to give me 12 and add to give me -8. So the factors of 12 are 1 and 12, 2 and 6. Can I get a -8 from there? Yes. Isn't -2 times -6 +12? And -2 plus -6 is -8. So those are going to be what goes in our parentheses, -2 and -6. And that's our final answer. Oh, I'm so sorry. I almost forgot about the 2 we ignored for a minute. That must be included in our final answer. So now if we FOILed this and then multiplied everything by 2, we would get what we started with. All right, let's look at the fourth one. So right away, I noticed these are 2 even numbers, and I know I can divide both of these numbers by 2, so that's what I'm going to do first. So half of 18 is 9x squared. Oops. And then half of 8 is -4y squared. All right, since I factored out this 2, I notice I have a binomial, so 2 terms, and guess what? They're both perfect squares, and there's a minus sign between them. So that means I'm allowed to find the square root of both and then give one a plus and one a minus. So what's the square root of 9x squared? Well, it's 3x and 3x. What's the square root of 4y squared? It'd be 2y and 2y. And since there's a minus sign, that means that one gets a plus and one gets a minus. And the last thing we do is bring down that 2 that we factored out. That's the final answer. All right. So that's how you're going to do those. When you have only 2 terms, but they're perfect squares and there's a minus sign between them, you get to factor it. If you had a binomial, which means only 2 terms, but there's a plus sign between them, the answer would be it's not factorable. We didn't have an example of that, but I'm pretty sure in Hogs you're going to have that example. So make sure you hear what I'm saying. All right. Now, sometimes you're going to try to factor something and you're going to say that it's not factorable. Well, that means that you're going to have to need a little help. You're going to have to use what we call the quadratic equation. So I told you a quadratic is an expression when you have a variable squared. Okay, so that makes it a quadratic equation. Now, an equation means you have an equal sign, right? So if you have an x squared, a variable squared, and an equal sign, that means you have a quadratic equation. So it says some quadratic equations can be solved by factoring, which is what we've been doing. Sometimes we can use the square root method, get the squared term by itself, take the square root of both sides. And then sometimes you have to use the quadratic formula. So this, what I circled, is the quadratic formula. Now, basically, when you graph numbers that are equations that have a variable squared, you're always going to get either a positive parabola like this, which is like a happy face, right? Or a parabola that goes down like a sad face. And sometimes you're going to have where those parabolas, which is what they're called, is going to cross the x-axis. Sometimes they will never cross the x-axis, and sometimes it'll cross the x-axis only in one place. Okay, so we're going to talk about those kind of patterns as we go through the quadratic formula. All right, now the first one we're going to look at, we're going to see that sometimes you need the quadratic formula and sometimes you don't. So let's look at this first one, okay? So the only difference in what we're looking at now and what we looked at earlier is that they have added equals 0 to these. So this first term, or this first equation, do we need a quadratic formula to factor this? Well, it's a binomial. There's only 2 terms. I noticed that they're both perfect terms or perfect squares, and they have a minus sign between them. So I can factor this without the quadratic formula. I'm going to find the square root of 64x squared, which is 8x and 8x. I'm going to find the square root of 25, which is 5 and 5. And since I have a minus sign here, that means that one of these gets a plus and one gets a minus. Now, like I said, the only difference now is that they added an equals 0. That means that if you multiply any number times 0, you get 0, right? So if this set of parentheses equals 0, and you multiply 0 times this set of parentheses, the equation would equal 0, and vice versa. If this quantity equaled 0 times another number, you would also get 0. So basically, what we're going to do is we're going to take each set of parentheses and set them both equal to 0. So if 8x plus 5 is going to equal 0. And since we have another set of parentheses, we're going to set this one equal to 0 as well. So now we want to see, okay, well, what can x be to make this equal 0? Well, if I want x by itself, I'm going to subtract 5 for both sides. So I'd have 8x is equal to negative 5. And then to solve for x, I'm going to divide both sides by 8. So if x equaled negative 5, we would get a quantity of 0. Well, we have another equation as well. So on this side over here, we're going to get rid of minus 5 by adding 5 to both sides. So we'd have 8x equals positive 5. And then when we divide by 8, we would say that if x equaled 5/8 or negative 5/8, this would be true up here. So what is our solutions? Our solutions are that x could equal either negative 5/8 or positive 5/8. And that is my solution. All right, let's look at the second one. So this is a coefficient of 1. So we're just trying to think of two numbers that multiply to give me 7 and add to give me 8. So what two numbers will multiply to give me 7 and add to give me 8? It'd be positive 7 and positive 1, right? Well, whoops, that should be a 1. That should be a 1. All right, well, since we are trying to get a quantity of 0, that means that either this first set of parentheses could equal 0, or even the second set of parentheses could equal 0. So, or when we set them both equal to 0, we want to solve for x. To get rid of plus 7, we're going to subtract 7. So x could equal negative 7, or if I solve the second equation, I found out that x could also equal negative 1. I don't know why I keep writing 7, or negative 1, I'm sorry. So either x could equal negative 7 or negative 1. So those are our two solutions. So when you have an equation with an equal sign, that means that you're solving for x. Earlier, we were just factoring. Now we're actually solving for x. All right, let's look at this problem. Now, anytime we are solving a quadratic equation, that means we want our equation equal to x, or excuse me, we want our equation equal to 0. That means we have to move this positive 12 over here so we can set this equation equal to 0. We want everything to the left of 0. Well, the only way to move that 12 to the other side of the equal sign is to subtract 12 from both sides of the equal sign. So this has a z, this has a z squared, and this is just a constant, which means that none of those are like terms. And I do want to put them in the equation, a plus b plus our constant by itself, c. So I'm going to rewrite this. I'm going to bring a up to the front, which is 7z squared. I want my b, which is to the variable by itself, second, and that's a positive 25z. And then my c, since I'm subtracting and my c is a constant without a variable, it's going to go last. And now since I canceled out this 12, Now I know that it equals 0. Okay, so now I could try the AC method. I could try multiplying 7 times -2, or excuse me, 7 times -12, which is -84. And I would have to think of two numbers that multiply to give me -84, but add to give me 25. And I can't think of an equation or two numbers that would give me those. That means I have to use a quadratic equation. So the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And if you Google a quadratic equation song, there's like a million of them, okay? So what we need to do is identify our A, identify our B, and identify our C. Don't forget the sign in front of it, okay? So the opposite of B would be -25 plus or minus the square root of 25 squared, b squared, minus 4 times a, which is 7, times c, which is -12. Put that all over 2 times a, and a is 7, so 2 times 7. Now, the way I put this in my calculator is I take what's under the radical only. So this part, I start with this part, and I just plug that straight into my calculator. I plug in 25 squared minus 4 times 7 times -12. And my calculator tells me that is 961. So I'm going to do -25 plus and minus the square root of 961 over 2 times 7 is 14. Well, now I'm going to figure out what is the square root of 961, and the answer is 31. That happens to be a perfect square. So I'm going to do -25 plus 31 divided by 14, and then I'm going to do -25 minus 31 over 14. These are two separate answers. So -25 plus 31 equals 6, and 6 divided by 14 is 3/7. So we're going to leave it in fraction form. So on the top we have 6, and on the bottom we have 14. So that would equal 3/7. Okay, so this equals 3/7. Now we're going to do the second one. We're going to do -25 minus 31, which is -56, and -56 divided by 14 is -4. So we have two answers. We have positive 3/7 and -4. And we only figured that out because of the quadratic equation. So our answers, our solutions are 3/7 and -4. So you're just going to have to practice typing that in your calculator and getting those solutions. All right, so it says solve the following quadratic equation by using the quadratic formula. Submit your answer as a fraction, reduce to lowest terms, or round your answer to 2 decimal places. So do you notice we have a letter A? So A is 6 because it's being multiplied by x squared. B is -6 because it is attached to this exponent raised to the first power. And then I don't see the letter C. Well, if you don't have a letter C, that means it has to be 0. Okay, so we're going to use a quadratic formula. So we're going to do the opposite of B, plus and minus the square root of b squared minus 4ac all over 2a. So the opposite of a negative number. So b is a negative number, right? The opposite of -6 is +6, plus and minus -6 squared. So what is -6 times -6? The answer is 36. This is always going to end up being a positive number, because whether you take a positive number and square it or a negative number and square it, you always get a positive number. So I go ahead and drop that negative sign, square whatever b is, and I go ahead and put it right here. You understand? All right, so then we're going to say -4 times a times c all over 2 times a. And in this case, a is 6. All right, so I take what's under the radical first, just what's under the radical, and I'm going to do 36 minus 4 times 6 times 0. And the answer is 36. Well, guess what? 36 is a perfect square. The square root of 36 is 6. So all of this right here equals 6. I'm going to do 6 plus 6 over 2 times 6 is 12. And then I'm going to say 6 minus 6 over 12. Well, 6 plus 6 is 12, and 12 divided by 12 is 1. And then 6 minus 6 is 0, and 0 divided by 12 is 0. So I have two solutions, and the answer is 1 and 0. So those both happen to be positive whole numbers. So those are my two solutions. All right, let's try another one. You guys pause the video, try it by yourself and see what you get. All right, the first thing I like to do is identify A, which is -5, B, which is 3, and C, which is -3. We're going to start with our quadratic formula. B squared minus 4AC all over 2A. All right, what is the opposite of +3? -3, plus and minus. We're going to square B. B squared is 9, minus 4 times A is -5, and C is -3. And all of that over 2A. All right, so under our radical, I start that with my calculators. 9 minus 4 times -5 times -3, and I get a negative number. Well, it depends on the directions. When you get a negative number under the radical, that means that you will not have your parabola. So when you graph this parabola, if that first number is negative, it means your parabola is going to go down like this, going to be a sad face. When you have a negative number under the radical, that means that this parabola is never going to cross the x-axis, because the square root of a negative number is imaginary, right? So then you have to read your directions. If your directions say to list the solutions, real numbers, you would have to put your answer is that the real numbers do not exist, because we ended up with a negative under our radical. However, sometimes it will accept complex numbers, which include the I. Remember that? So we're going to say that -3 plus and minus, remember the square root of -1, I'm sorry, a negative number. So in this case, it's -51. So first of all, can we, let's see, can we break 51 down? No, we can't. All right, so we're going to say it's -3 plus and minus I square roots of 51 over 2 times -5 is -10. So that's our first answer, and we just pulled out the I. We pulled out the -1 times -1 times the square root of -1 times the square root of 51, which is I square roots of 51. And then when we can simplify this, if we have a negative, a negative, and a negative, we actually end up with a positive I square roots of 51 over +10. And also the second number would be 3 minus I square roots of 51 over 10. So these are two numbers. These are two solutions if it asks for complex numbers. If it says what are the solutions, list only real solutions, that means that you're going to say it does not exist. And when you have an answer does not exist, that means that when you have a negative parabola, it's never going to cross the x-axis. That's what it means. So this equation right here, when we graph it, will never cross the x-axis. There are no x-intercepts, okay? All right, so let's look at this one. It says solve the following quadratic equation by the square root method. If needed, submit your answer as a fraction reduced to lowest terms. So we already see that our equation is set equal to 0, so we're good as far as that goes. Now we have to square 5y plus 2 times 5y plus 2. And then we're going to add 25 to it. So we're going to FOIL this. 5y times 5y is 25y squared. 5y times 2 is 10y plus 2 times 5y is 10y. And then 2 times 2 is plus 4 plus 25 equals 0. Well, now we're going to combine all those like terms. So these are like each other and these are like each other. So we're going to have 25y squared plus 20y plus 29 equals 0. So now we're going to use a quadratic formula. So y squared, so our a is equal to 25, our b is equal to 20, and our c is equal to 29. So we're going to do the opposite of b, plus and minus the square root of b squared minus 4ac all over 2a. So the opposite of b would be negative 20 plus and minus the square root of 20 squared. So I think that's 420 times 20, 400 minus 4 times 25 times c all over 2a. So 2 times 25. All right, I'm going to put what's under the radical first. 400 minus 4 times 25 times 29 is negative. Once again, I have a negative number, 2,500. So what's under the radical is minus 2,500. So when I have a negative under the radical, that means it will not cross the y-axis. No, the x-axis. It doesn't have an x-intercept. So if it asks for real numbers, we're done. It doesn't have a real number. It doesn't have any real solutions. But if it asks for complex answers, then we'll continue. So then our denominator is 50. So 2,500 is a perfect square. It's 50. So think of this as 2,500 times negative 1. So we would bring out the I, which is our square root of negative 1. And then, it's a perfect square, right? Oh, shoot. So it's not the square root of 2,500 because the square root of 2,500 is 50. So it would be 50i. Let me get my pen if I can figure this out. Plus 50i over 50. So that would be, we're going to do 1 with plus 50i over 50, and then we're going to do 1 with minus 50i over 50. And we could divide all of this stuff by, let's see, 10. So if we divide, so here's our two solutions before we simplify them. If we divide everything by 10, 10, 10, that's what we can divide every single term by. We would have -2 plus 5i over 5. And then the bottom one would be -2 minus 5i over 5. So those would be our two simplified expressions if they allow for complex numbers. All right. All right, we got two more, you guys. All right, so once again, we're going to square this, and then we got to move that 18 on the other side of the equal sign. So let's do 8x plus 20 times 8x plus 20. And then if we get rid of positive 18, we would subtract 18 from both sides. We're going to write minus 18. And now we can set it equal to 0. So 8x times 8x is 64x squared. And then we have 8x plus 20. So that would be 160x. And then do it again, plus 160x. And then plus 400 minus 18 equals 0. So then these two are like terms, and these two are like terms. So we have 64x plus, what would that be, 320x plus, what would that be, 400 minus 18 is 382 equals 0. I know I could divide all of those numbers by 2 at least. Yeah, just 2, I guess. So that would be 32x plus 320 divided by 2 is 160. Oh no. What did I do? Oh my gosh. I did it. I did it again, you guys. Oh my goodness. Now. Oh. Okay. Okay. Well, darn it. Where was I? So we'll just go with the 64x squared plus, what would that be? 160 plus 160 is 320 plus 400 minus 18 equals 0, and then 400 minus 18 is 382. So 64x squared plus 320x plus 382 equals 0. I could divide by 2, but I don't have to. So let's do A equals 64, B equals 320, and C equals 382. So now we're going to do the opposite of B, plus and minus the square root of 320 squared is 102,400 minus 4 times 64 times 382. I think we're going to end up with a negative number. All over 2 times 64 equals 0. So we're going to have that big number minus 4 times 64 times 382. No, it's not a negative number. It's 4,000. So we're going to have negative 320 plus and minus the square root of 4,608 over 64 times 2 is 128. All right, what is the square root of 4608? It's not a perfect square. Oops. All right, so 67 times 67 is 4482. So what is 4608 minus 4489? Let's see, 4608 divided by 4489. I don't know what I could divide that down into. That's a big number, isn't it? 4608 is going to be, 67 squared. 4489. Well, that is too big of a number to simplify, isn't it? That is such a big number. I don't know why this is an example. So anyway, hopefully you won't get these numbers that are that big. So we're just going to call this a practice problem. So when we meet during class, hopefully your numbers will be a lot smaller. So I'm not going to waste time trying to simplify this. It can be simplified, but I want to do the last problem for you so you guys can get off this video and start doing your homework problems. But if you have questions while you're doing your homework problems, make sure you come to class and I'll help you with them, okay? All right, so you will have a couple of word problems. So for example, like this one, it says a rectangular auditorium seats 1,598 people. So we have a rectangular auditorium. Well, auditoriums have rows and they have seats, right? All these seats and all these rows. The number of seats in each row exceeds the number of rows by 13. So let's say there's 13 rows. Well, the number of seats, it says the number of seats in each row exceeds the number of rows by 13. So we don't know that there's 13. Let me get rid of this. So however many rows there are, which we don't know, we do know that the number of seats is 13 more than the number of rows, right? And we know the total that the auditorium set seats is this. So basically, we're trying to find the area of this auditorium. So we're going to multiply, just like a rectangle, you're going to multiply the base times the height. So if the base is x plus 13, and the height is x, we know that this auditorium, the area of this auditorium is 1,598. So that's our equation. So now we're going to distribute that x. So x times x is x squared. X times 13 is 13x. And we want since it's a quadratic equation, we want it set equal to 0. That means we want this number moved to the other side, right? So we're going to think to get rid of positive 1,598, we're going to subtract it from both sides. And now we can set it equal to 0. So what we want to do is think of two numbers. We could use a quadratic formula, but we don't have to. Think of two numbers that when multiplied end up being negative 1,598, and when we add them, we want to get 13. So to tell you the truth, guys, this is a guess and test. So we want two numbers that multiply to give me 1,598, and they're 13 digits apart. So I'm just randomly going to start dividing 1,598 by numbers. So I start with 13, I'm going to divide it by 16, I'm going to divide it by 32, I'm going to divide it by, I'm guessing and testing, divided by 34, oh, and that's it, you guys. I guessed it very quickly. So basically, I guessed and tested, because I have a calculator, I divided the total 1598 by 34, and I got 34 and 47. So double check it. Does 47 times 34 equal 1,598? It does. And are they 13 numbers apart? Well, 47 minus 34 is 13. So I know that the two numbers have to be 34. So X has to be 34 and Y has to be 47. Now, I know when I read this problem, I know I have to have two numbers that equal this and are 13 numbers apart. So I could use this equation right here and use a quadratic formula, and it would give me the same two answers. But I also know that doing guess and test is just as quick. So as long as it meets the criteria of being 13 numbers apart and that the two numbers multiply equals the total number of people that can be in the auditorium, I know that that's going to be correct. All right, so just a little extra help there on these word problems. All right, so that was it on this section. Oh, do we still have to do one more section? Oh, that was what you're supposed to do for homework, okay? So make sure you guys get done 5.R.3 and 2.3 for Monday or Tuesday, and then the other class I'll make you guys another video. All right, see you guys for class. Have a great night. Bye.